Hi, in this week's video we'll be taking a look at the AQA Topics Test 1, 20 minutes, and it's an algebra recap and review for the higher tier. So we're looking at, I would say, grade 5 to possibly even grade 7 actually. So, so we're looking about grade 5, 6 and 7, okay, for these sort of questions. So it is explicitly for higher tier, although I would say possibly the first maybe 6, 7 questions may be appropriate for the foundation tier as well. Okay, so feel free to tune in on it if you're doing foundation as well, and feel free to drop off here at any points that you might not think is relevant for you. Okay, this is question number 1, guys. Circle the line that is parallel to y equals 2x plus 8. So parallel means it has the same gradient. So the equation of a line is equal to y is equal to mx plus c, where m is your gradient and c is your y-intercept. So where it crosses on the y-axis. So the number here is 2. So we want the equation to have a 2 in it. It can't be that one because it's a half. Can't be that one because it's a minus 2. Looking here, well, if I add 2x to both sides, I get y is equal to 2x. So it is going to be this one, yes. Okay, so parallel means it has the same gradient. So the lines never meet. Okay, and this one, if you're interested, the gradient is equal to minus a half. Okay, so that will give me the answer for question 1. Okay, so this one has a gradient of negative a half. Okay, this is question number 2, guys. Circle the line that is perpendicular to y equals 2x plus 8. So perpendicular is the negative reciprocal of the gradient. So currently the gradient is equal to 2. The negative reciprocal, so I'm going to label it as PM for perpendicular gradient. Okay, so the reciprocal of a half, is 2 is a half, but I stick a minus sign on the front, so it's going to be equal to minus a half. So the gradient has to equal minus a half. Well, it can't be this one, because that's got a gradient of a half, not minus a half. It can't be this one because it's minus 2. It can't be this one because it's parallel, so it has to be this one here, okay, because the gradient of this one is equal to minus a half. Okay, because it's a number in front of the x. Imagine that I've got a 1 in front of the x there. Okay, 8 divided by 2 is 4, and then I've got minus 1x over 2, which is the same as saying minus a half x. Okay, it's just like a convention way of writing it. This is question number 3, guys. Circle the line that passes through the origin. Well, that's where the value of c is equal to 0, okay? So it's just y is equal to mx. Now, if I rearrange this one, I get y is equal to 2x, so it has to be this one, okay? This has got a plus 8 here, so it can't be that. This one's got a plus 8 as well, and this one's got a plus 4, okay? If I simplify this fraction, 8 divided by 2 is 4, so it crosses the y-axis at 4. This is question number 4, guys. Work out the line, okay, 2y minus 3x minus 0 crosses the y-axis. So the y-axis is when x is equal to 0, okay? That's the y-axis. So I'm going to have 2y minus 8 is equal to 0. I've got a linear equation, so if I add 8 to both sides, I get 2y is equal to 8. Dividing both sides by 2, I get y is equal to 4, because 2y means 2 times y. Okay, so the coordinates would be 0, 4, okay? For that question, and I think it's made like a typo here, because I think this one's wanting the x-axis. So the x-axis is when y is equal to 0. So if I solve that, I get x is equal to minus 8/3 when y is equal to 0. Okay, so if you're interested, it crosses the x-axis at minus 8/3 0. Okay. for that question. So the x-axis is setting y is equal to 0, but to answer the question, it crosses the y-axis at 0, 4. This is question number 5, guys. Here is the graph of a straight line. Work out the equation of the line. So the equation of a line is in form y is equal to mx plus c, where m is your gradient and c is your y-intercept. Well, straight away, I can work out the value of c because it crosses the y-axis at positive 6. So I know that my equation is going to be y is equal to mx plus 6. So straight away, I've bagged in a mark there just by identifying the key feature of the graph. Okay, so knowing what my m and plus c stand for. So m is gradient, so how steep it is, and c is my y-intercept, and I know it crosses the y-axis at 0, 6, or just 6. Okay, now what I need to do is I've got to work out the gradient. So the gradient is the change in y divided by the change in x. So how steep it is, okay, so the height here divided by the width. Okay, so it's going from 6 to 0, so it's going down 6, so it's minus 6, divided by, it's going across 2. Now minus 6 divided by 2 is minus 3, or negative 3. Okay, so therefore I can deduce that my final answer is y is equal to minus 3x plus 6. Okay, and I would not recommend writing it as 6 minus 3x because examiners, generally speaking, for AQA, Edexcel and OCR would want it in the form y equals mx plus c. It's only when we start doing A-level maths that it can be expressed in different ways, okay, but we always want it in the form y is equal to mx plus c. Okay, so it's the change in y divided by the change in x. Okay, so it's the change in y, delta y over delta x for the gradient. Okay, so rise over run, we say. The rise divided by the run. Okay, this is question number 6, guys. Solve the equation 3x plus 14 is 2. Well, if I subtract 14 on both sides of my equation to balance it respectively, okay, 2 minus 14 is equal to minus 12, so 3x is equal to negative 12. 3x, we know it means 3 times x, so dividing both sides by 3, I get x is equal to negative 12 divided by 3, which is negative 4, or minus 4. Okay, this is question number 7, guys. Here is the graph of y equals 3x plus 1. Use the graph to find the solution 3x minus 1 is equal to 0. Well, I'm looking at the line y equals 0, which is actually the x-axis. So I'm looking at this point here. Okay. So that, to me, okay, tells me that x is equal to a third, okay, by looking at that graph. Okay, I appreciate it is a bit tricky looking at it on a screen, but feel free to pause it and zoom in on this graph, okay, but it does cross, okay, because every square, I believe, goes up in a fifth, okay, so there's 1, 2, 3, 4, 5. So it's going up in a fifth, like each time. Okay, and it's just under 2/5. Okay, so it's just in between the first and second square. So yeah, it's greater than a fifth, but smaller than 2/5. Okay, so it's a fraction in between there. Okay. And I got the answer to be a third, okay, because a third satisfies this inequality region. Okay, so hopefully it makes sense, okay. But again, feel free to pause it and double check my answer. This is question number 8. Solve the equation 5x plus 1 is equal to 2 brackets x plus 4. Well, expanding the brackets on the right hand side, I'm going to get 5x plus 1 equals 2 times x, which is just 2x, and then 2 times positive 4, which is positive 8. So I get 5x plus 1 is equal to 2x plus 8. I'm now going to subtract the 2x on both sides because I want to try and get all my x's on one side of the equation and all my numbers on the other side. Okay, 5x minus 2x is 3x. 3x plus 1 is equal to 8. While subtracting that 1 on both sides, I'll get 3x is equal to 7. Okay, subtracting 1 on both sides, dividing it by 3, I get x is equal to 7/3. Okay, 7/3. Okay. Right guys, we will look at question 10 now and then I'll come back for question 9. So this is question number 10. Plot the graph y is equal to 8 times 2 to the x for the values of x from -3 to 3. Use a table to help you. Okay, so when x equals 1, 2 to the 1 is just 2 times 8 is 16. Okay, so this is what I call like an exponential graph. Okay, when x equals 2, 2 to the power of 2 or 2 squared means 2 times 2, which is 4. 8 times 4 is 32. Okay, so it's essentially doubling each time. This is going to be 4. And this is going to be 2, okay? So every time the x-coordinate changes, okay, or goes up by 1, the y-coordinate doubles, okay? And then I've got to plot this graph, okay? So -3, 1, okay? So that's a bit there, okay? -2, 2, that's going to be there. -1, 4, that's going to be the second square, okay? 0, 8, so that's going to be here, okay, 1, 16, that is going to be just above the middle, so around here I want to say, okay, 2, 32, that's going to be there, and then 3, 64 is going to be there. Okay, so again, drawing this freehand, I'm going to get something like this as my graph, okay. Question 10b, guys. Explain what happens to the value of y when x is a very large negative number. Well, it gets closer and closer to 0. Okay, so it gets closer and closer to 0. But it never actually reaches it. Okay, and the reason for that is because the curve is what I call an asymptote to the x-axis. If I set 8 times 2 to the x is equal to 0, there's no solution for x such that this equation is satisfied. I can divide it by 8, that's fine. I'll get 2 to the x is equal to 0 divided by 8, which is going to be 0. But there's no number that I can put into here, 2 to the power of something, that will give me a negative, give me the answer of 0. So closer to 0, okay? And it comes from that idea, okay? So we say that the curve is an asymptote. So those of you doing A-level maths may have come across what it means by asymptote, okay? So asymptote just means that the curve or circle or whatever sort of curve I'm looking at, okay, gets closer and closer to the y or x axis or that particular point, but never reaches it because I can't solve an exponential equation, okay? Anything to the power of x is equal to 0. That's not actually possible to solve, okay? So it doesn't have any solutions, okay? But we say that as x tends to a really small number, okay, then it will get closer and closer to 0, okay? So if I have like 2 to the negative, let's say 10, it will be like 1 over 2 to the 10 next year, which is going to be a very small number on your calculator, okay? it'd be like 0.0000 whatever, okay, etc. Okay, so 0 point something, okay, 0.00123 we could say, okay, for that one. Okay, that isn't the actual answer, but it's just making one up actually, yeah, for the value of x. Okay, and feel free to test any numbers smaller than 10. Okay, we'll now come back to question number 9. Amy cycles from home to the park, or to a park and back home. The graph shows her journey, distance from home, and time. Amy stopped at the park for 15 minutes, so that's going to be this part here. Okay, work out her average speed, okay, from home to the park in kilometers per hour. Okay, so we are looking at essentially the area under this part of the graph, if that makes sense. So what I can do is split it up, okay, into different shapes and see what we get. Okay, I've got a triangle here, I've got a rectangle, and I've got a trapezium. Okay, so this one here, the area of the triangle, so I'm going to label that as T, is base times height divided by 2. Well, it's going to be 30 times 5 is 150, divided by 2 is going to be 75 kilometers. Okay, but the time is in minutes actually, so I need to actually change that. So 30 minutes is half an hour. Okay, so the speed we should know is distance divided by the time. Okay, so distance is equal to 5 kilometers divided by the time it takes, which is half an hour, so divide it by half. Now divided by half actually doubles our answer, so that's going to be equal to 10 here, so 10 kilometers per hour for that part. Okay, so make sure that you swap your conversions very, very, very carefully here. So that's going to be 10 for that part. Okay, for the rectangle, we're going to have the area of it. So it's going to be from 30 to 75. So that's going up, it's going across 45. And it's going up 5. Now, 45 minutes is equal to 3/4 of an hour. Okay, so I'm going to have 5 divided by 3/4, so times by its reciprocal, so 5 times by 4/3 is going to be 20/3. Okay, so it's going to be 20/3 for this one. Okay, so they are a bit like nasty numbers here, but we can deal with them at the end. And then if we look here, okay, I want to work out the area of the trapezium here, which is a bit more trickier. So I'm going to have, although it's not a trapezium actually, so that's going to work out that part there. Okay, so let's just delete that part. So we worked out the area of this and the area of this, but we've got to work out the area of this part now, which is a bit more trickier. Okay, I'm going to have to put like a line there, so we have like a trapezium and then a triangle here, and then we're going to have to add up our answers. Well, that's going to be, so here it's going from 45 to 75, so that's going to be half an hour. Half an hour in 5 kilometers. Well, 5 divided by half again is going to be 10. So that's going to be 10 there. And we're going to work out the area of this trapezium. Okay, so it's going to be A plus B. So it's going to be this distance here. Well, we've got to obviously convert that into hours. So it's going to be 45 plus 30 is 75. 75 is 1 1/4 of an hour. Okay, so it's going to be 5/4. Okay, 5/4. If I double that, then I get 10/4, which is going to equal to 5/2. Okay, sorry, I'm dividing it by 2, not timesing it by 2. So 5/4 divided by 2 is going to be 5/8. And then 5/8 times the height. Well, we're going from 15, going from, 15 to 5. So we're going to have 5/8 times 10, which is going to equal to 58. Okay, so 58, which I can simplify to 25 out of 4. Okay, and if I add all my answers together, so I'm going to have 10 plus 10 is 20, 20 plus 20 over 3 plus 50 over 8. Okay, well, I can work this out actually. Okay. So if I add this, so 20/3, okay, plus 25 divided by a quarter, plus 20, okay, I get the answer, now it's a decimal, I get the answer of 32.92 kilometers per hour, rounding that to 2 decimal places. I get 32.9166666667 on my calculator, but I've rounded it to 2 decimal places, and I get 32.92 or 33 to the nearest whole number. Okay, and that's how to work out the average speed. Okay, so essentially it's the area under this part of the graph. Okay, from here to here, essentially. Okay, so if I shade in all this, is the area under the graph. Okay, essentially. Okay, remember that speed is distance over time. Okay, so I hope that actually made sense, guys. Sorry if I waffled on actually a bit for question 9, but hopefully it made sense. Any questions, any queries, put it in the comment section. Thank you so much for watching. If you're new to my channel, please press that subscribe button, drop the video a like, and lastly click that bell icon so you don't miss out on further and future uploads for Key Stage 2, Key Stage 3, GCSE, and the occasional A-level pure and A-level further pure maths. Okay, but that's it for me today, guys. Thanks for watching, and I'll see you for the next one. Bye for now.